Okay, everybody. Thank you for coming here and to the talk. It's called Technical Content Grimoire, Volume 1, because I think there might be more as the time goes on. Obscure techniques for better development and visual candy. You'll see why I mean visual candy, because I'll talk about different techniques how to make your game look more interesting across a wide configuration setups. My name is Tomislav Božić, and I am a technical content designer, which is a conglomeration term for me. I kind of came up with it, where I do a lot of level art stuff. I am the lead, or I'll say the main lighting artist at Croteam, technical artist, and well, resident content fixer. When where any content fires may came up, I come and save the situation. So a little bit about Croteam. Croteam is one of the oldest gaming studios in Croatia, based in Zagreb, the capital. And they were there since the 90s, even before I was born. And they may be the most famous for the Serious Sam franchise, and somewhat lately the Talos Principle franchise, a philosophical puzzler. And even the latest one, Talos Principle 2, was our latest game, and we just, like last week, we released the only DLC we have for it. And maybe one of the most special things about this project is it was our first Unreal Engine game. We first started in Unreal Engine 4, and then later came to 5. And this whole talk was pretty much derived across those 3.5 years as we were making Talos. So in this grimoire, I'm going to talk about different techniques that we either found out about, not necessarily through like your ordinary YouTube and Unreal Engine forum digging. A lot of them I think are somewhat obscure, and some of them we came upon as custom solutions through some experimentation and as we found different needs for them. This is generally what we'll be talking about. So multi-pipeline lighting, which means how to handle your lumen and non-lumen lighting and how should they look. Flexible landscape material system, handling third-party assets, manual PSO caching, local volumetric fog, VSSM invalidation optimization, and if I have the time at the end, I'll talk about some world partition performance test we did post-release of Talos 2, which if anything, I want to trigger a discussion about world partition itself, well, more specifically streaming in world partition for different types of world sizes. So let's just go straight into it. Multi-pipeline lighting. Just to preface everything, when we started work on Talos 2, we started in 4.26, where you had your dynamic lighting, which we first started testing and using because it was much easier to work with. But I think, as everybody knows, by default, dynamic lighting in Unreal 4 is not really that great. And as we then started working with pre-baked lighting, there was a whole other can of worms that I am so happy I don't need to revisit ever again in my life. After that, we moved to Unreal Engine 5, and primarily because of Lumen, because we wanted a high fidelity game with not too much work, I guess. And Lumen came in really great. But one caveat there is because you have Lumen, you have only dynamic lighting, and not all configurations like your NVIDIA 1060 GPUs and I don't know what's the equal case for AMD. They can't run Lumen, so you are back to your old Unreal Engine 4 dynamic lighting, which is generally really ugly, especially indoors. And in my opinion, it's all because of large-scale unshadowed skylighting. Ignore the distance field ambient occlusion because that's not really a fix for all your panes, especially indoors. I'll show you what we did and how we've done it. First, before I want to just show you, to the left is your lumen scenes, and to the right is your non-lumen scenes, but without any modifications and any work done to them. And Now, we did a two-part solution. Well, I would say two and a half part solution. First part of it is a lumen-adjusted Skylight, which is pretty much, I don't know, I think the programmer who actually did this one is here, but solution to it is basically a child class of Skylight that pretty much has separated Skylight color and intensity for lumen and non-lumen settings. And it is done in runtime, pretty much. So if you can disable lumen in runtime, so this should also work in there. And pretty much what we and other level artists did, well, primarily I, because I do lighting there, we would, the whole point of this solution would be to get the grand mood of non-lumen lighting closer to your lumen lighting. Because you will never be able in dynamic lighting to replicate your GI from lumen to down to your non-lumen lighting. But with different tweaks of color and intensity, you can definitely bridge that gap much closer. Especially in this example in a desert landscape where you have a lot of red bounce lighting from the rocks, from the landscape, and you get a very nice GI in there. But you will see here to the left, the non-lumen unadjusted lighting is very lacks saturation, lacks character. It's very, we would call it washed out. And to the right, it's a directed and adjusted Skylight for non-lumen. Here in the video, you can see like live how that all happens to be. So I'll just go and disable lumen. In your ordinary Skylight, if you did this, the lumen Skylight would also be colorized. And here is just your ordinary white Skylight. It's not really biased like that. Now, the second part of the solution is mostly for interiors because the Skylight solution is generally for your global, larger world, exteriors pretty much. But this one is for your interiors. And it's called Skylight Fade Volume, which is basically your brush volume, like your post-process or whatever else you use your volumes for. And it works in a sense where it has a direction. If you're going forward in direction, the concept would be as you're entering your interior, the Skylight intensity and color or color, if you want to, you can only just adjust the color. The color will lerp between the outside and to the inside values, pretty much. And the setup for it is, and it's designed to work in runtime, of course, and the setup for it is kind of tricky. At least it was for Talos 2, because as we were working in production, it's all hectic. You can't really think about user experience. It's generally comprised out of two volumes: the main, the entrance volume that actually does the fading, and the main volume that caches the target fade, the target Skylight color of the interior, and just has it all the way through inside the volume itself. So there is some heavy authoring you have to do to follow the shape of the interior and to just keep the overlap between the two volumes consistent. So there was a lot, as we were like hectically producing the game, there were a lot of mistakes where you would enter, let's say, a lab here, and you would see like flicker, like just slight flicker of the light. And it's because you would have a very, very small gap between the volumes. So the volumes should be intersecting in this case. Here's a real quick show. Here, this is your lumen lighting. This will be your unadjusted lumen without volume. And here you'll see how it works with the volumes. If you look for it, you can see the fade in and fade out. And another thing you might have, I'll just let it go through again. Another thing that's the half solution that we did is, you see how the doors are very dark. We used a plane that has a simple translucent shader that basically blends opacity depending on the distance from the player. It's your ordinary distance-based mask. Okay, and with that, I think we made a really great connection between Lumen and non-Lumen skylights for various atmospheres and various lighting setups. Now, the second thing I want to talk about is the flexible landscape material system, which I was pretty involved in, and what we ended up doing and why we actually made it. Now, we wanted a flexible system where, for a quick level iteration, we've in Croteam before Unreal Engine 5 and Talos Principle 2, we had our own serious engine. It was an in-house engine. And in there was a terrain system which was very, very flexible, I'd say even very advanced for the time it was developed for. And it had a very flexible and very user-friendly material system that we used, and we were very used to it. So I wanted to somehow replicate that in Unreal Engine if possible. I know that the very engineering quest wasn't really possible for me as a tech artist. Well, I'd say a tech artist, I don't really do too much code. But what I was given in the material editor, I would at least try and do the material setup somewhat easy. So some compromises needed to be made, and the editing wouldn't be that easy, and just the construction wouldn't be that easy. But the end developer, when level artists use it, it's fairly straightforward how to use it. The development of that system was started at the very beginning of the development, and even to this very day, I am doing different updates and removing parts that we ended up not using, and just upgrading with new and different features. So I'm just going to go through some features of the system I think are pretty interesting. So for the very core of the material system is we have 14 texture layers, which are weight blended, well, height blended, but it's still a weight blend with height term, and 4 utility layers that are alpha blended. And when it comes to those 14 texture layers, they're comprised of your base color, normal, and it says here ORDP. We generally use Megascan surface assets for terrain since we are generally photorealistic art style. So they use that ORDP format. So it's occlusion, roughness, and displacement. Generally don't use occlusion, so it's pretty much wasted. Roughness and base color and normal are written into the RVT, so we extensively use RVT for our landscapes. And the displacement is used for the height blend. And lately, what I'll also mention later, we are using for a nanite displacement tessellation displacement. One thing that's not great for me is that the number of those layers is hard-coded in the material editor, and each time we want to add another layer, if someone really wants 15 layers, but before we started with 8 layers, and then we just gradually increased to 14, and we said, okay, stop, not anymore. You have to copy this whole segment and copy all the parameters here, and just do all the boilerplate renaming, and it's just very, very tedious. But this type of thing, why we have so many layers, so many parameters per layer, is just to have that ease of editing, and you can just edit a lot of stuff in there. You don't need to edit your color saturation. You don't need to edit your contrasts in your displacement textures. So it's your ordinary master material, but for landscapes. That's what I always wanted to achieve with it. Now, I'm going to talk briefly about the 4 utility layers. One of them is puddles, which is fairly simple and self-explanatory. And it's very flexible because it can. For Talos 2, I even implemented, for example, I implemented rain ripples, but we never had any rain, so I just like cut it out. But for future projects, the function is still there, so I can just put it back in, and it will, with the magic of material code, it will work as like a charm 90% of the time. Second utility layer is a landscape grass mask layer. So we basically, as you can see in the video, no matter what type of layer, texture layer you have, if you draw a landscape grass mask layer in that spot, the landscape grass will not spawn there. It's very useful for different cases. Maybe the best case would be if you have an interior that's very close to the landscape and you don't want to bring the landscape down, but you have a grass protruding to your floor, just draw a mask for the landscape grass there, and it will work, and you won't have to like repaint with, I don't know, a texture layer that's like gravel, but even gravel can sometimes have some grass on it. Second one is pretty much self-explanatory foliage mask layer. It's the same as the previous one, just for foliage. One thing to note is you have to, in your procedural foliage, this is for procedural foliage, in your procedural foliage type spawner, you have to mark foliage mask layer as your exclusionary layer to not spawn your foliage instances with it. And the last, but not the least, but maybe the most esoteric one, is normal remove mask layer. And that was used primarily for cliff faces, because we were extensively using RVT blending, and when you have like a cliff in a landscape and it goes like this, then you put your cliff meshes here, and we did an interesting thing when the top of the cliff would be blended with the landscape through the RVT blending. The normal from the landscape mesh would create a harsh, dark line alongside the cliff, so it would look very strange, even up close and from afar. So I just made a normal subtraction function where you just put a normal that just looks up. It's a 001 normal is being pretty much masked there, and it solves the problem, no problem there. And it is a fairly niche use, but without it, you would see a lot of artifacts because we had a lot of cliffs in Talos 2. Now after the layers, I'll just talk about some different features we have. One of them is how we handle tiling. We don't use any texture bombings, no stochastic sampling or any other like esoteric magic stuff. We just use distance-based sampling of multiple texture frequencies. So we have your near texture, that's your ordinary, your base texture tiling. Then we have mid and far texture sampling, and they're just being masked by distance, but through virtual texture MIPS, not through pixel blending, because we use RVTs, and the tutorial said that's what you're supposed to use. We also have the implementation for macro stains and macro normals, but we ended up never using them because we never saw the need, and it's just another texture that you are using, and it's just another memory cost that you have to endure. So just to disclaim, we have removed the macro stains and the macro mask from the shader right now. You can see the tiling, but you can see that it's pretty much, you can see it even on the naked lands. Grass does wonders for that. Another feature that we have is the glitter term. It's great for snow and sand. It's your ordinary glitter, and we don't we use just a simple mapping on the landscape. We don't use any camera projected magic stuff with it, and it really does add that it adds that depth of and the feel for those specific materials. And as you can see, this is how we set it up. We set it up per layer, so you don't really need to paint anything. Previously, the glare term was also like a utility layer, but it was very clunky to use. And with hindsight, I don't know why it made it like that. So this was much easier approach to it. Now, with all those features behind us, I just want to talk a little bit about some shortcomings with the landscape system itself and what problems I encountered, and maybe what's something to think about for the future. One thing that we definitely encountered a couple of times during production is subsurface. We had a lot of snow biomes in Talos 2, and if you notice, we don't have snow subsurface in those levels, because subsurface cannot be transferred with RVTs onto the blended objects. You can transfer the normal, you can transfer the roughness, the specular, and the color, but if the landscape has the subsurface, that specific layer of snow has subsurface, the snow that's the snow that's on let's say a rock will lack subsurface, and it will definitely be like, okay, this looks like flour, but this looks like snow. So there's definitely a problem there. So we opted to not have subsurface at all. So it will be much harder to spot that there's actually no subsurface there. It still looked fine in the grand scheme of things. So we weren't really sad about it. Second thing, I am always thinking about how can I even more improve the workflow of just editing the landscape material, and how to improve the overall usage of the material instance for the landscape itself. I was thinking about implementing this type of system into the material layering system in Unreal, but it's pretty much impossible in my experience due to the material actually using RVT. I don't think it's that compatible. And the last thing that I just want to mention is the problem with the workflow is landscape grass. Because landscape grass is set up inside the master material through the landscape grass node, you cannot externally, through an instance, set and override what each layer will have, what landscape grass asset will have, will be on the layer. So that cannot be done through an instance. It has to be done through a master material. So by that fact, all of our each of our levels had its own master landscape material, which is pretty much just two or three material functions that had the bulk of the functionality of the landscape system, just duplicated over and over for each level, and we just had to rename the master material, make an instance out of it so you can edit it properly, and that's how we ended up with a lot of landscape materials. Thankfully, we didn't have much, we didn't have many, and we didn't have hundreds of levels to just worry about that. A little bit about future work. Of course, I'll always try and do and use whatever new comes with the RVT system, maybe hopefully sometime in the road. Don't get me wrong, I have no idea how the RVT works in a sense of the code base, how easy it is to just expand. But I hope for the future that we can have our own custom data set in the RVT, custom texture types set in the RVT, so we can actually have subsurface, so we can have an isotropy, for example, or some other different texture types. Something I already did in the background is integration of the nanite tessellation, and also dynamic boot footprints with that set tessellation. And it's pretty fun looking forward what's new for the landscapes. Now, after this, I'm going to talk about a little known thing called third-party assets. I don't know I'll try and see, show of hands in your projects, how many of you are using some third-party assets from, let's say, Unreal Marketplace or ArtStation? So everybody. Yeah. So a lot of us have and are in studios or like maybe 1, 2, 5-person developer studio, and you have big ambitions. We like big ambitions. We like GI, dynamic GI, photorealism, rock that has 10 million polygons. But sometimes that can be and tends to be a curse, I'd call it. So it was the same for us. In Croteam, we are a small team, what about 40 people, I would say. We had big ambitions. We want ours to be photorealistic, high fidelity, high detail game. So, of course, we opted for Unreal Marketplace. To fill all the biomes that we wanted. We have like 4 or 5 biome archetypes, and we just couldn't, with the amount of people we had, we couldn't like produce all the assets we needed for it. One thing we expected from third-party assets to have a faster VisDev, fast iteration on prototyping the visuals, which is true. It's much faster to visualize and prototype your visual style and visual identity. But the problem happens that if you heard about what is called development debt, code debt. This is content debt. This creates content debt that will haunt you until you fix it. So, what are the problems? One of them was, well, a lot of master materials. One day, our lead programmer, who's here, I think he'll definitely remember this, he came to one of our daily art meetings and gave us a log file that I think said we had like over 1,000 master materials in build. And we were like, oh, really? Didn't know that. And it was kind of a concern in the background of our heads. We knew that we had to do something, and I was always trying to just like move it forward and say, okay, we need to do something about the sheer different material standards that you get with different third-party packs. So when we actually got that info about how dire it was, we tried to do, and we did a material consolidation. Well, I did material consolidation, and that lasted, several days. I think it was like week or 2 weeks, I think. And I went through all the levels. I built a custom like debug visualization setup via material parameter collection. So when I open that parameter collection and say, okay, I set a float to 1 for the in-house debug parameter. I put a material function on all materials that were in-house materials, and so they would be colorized. The base color would be, I think, pink. So everything that was pink in base color in viewport, that was using our master materials, and everything that wasn't colorized, that just had normal base color that it had before, that's the actor that had the material that had to be consolidated. And that took, as I said, about 2 weeks to do it. And even to the very end, till the very release, I was still finding different assets here and there that needed to be consolidated, because you can't really begin to think that you can actually get them all in bulk when you are just doing it. So it took some time, and we learned a lot of lessons with that situation. So take this as a cautionary tale segment. Second problem that we kind of encountered was the nanite pipeline compatibility. It's generally a thing that happens when you actually go from Unreal Engine 4 to Unreal Engine 5. We already had a lot of third-party assets from 4. So we had, and when we actually decided to go a nanite route, we actually went and said, okay, we're going to do a full nanite pipeline. We had to go through all the third-party assets and all the levels too, just to see what's nanite and what's not nanite, and just to see, okay, is this nanite? How do we do it? So the search itself was pretty easy. The general conversion job itself wasn't that big of a problem. There were a couple of cases that were like a pain, in a sense of it was a pain spot. Let's say there was a mesh that had two materials. One would be like a metal, and one would be glass, which was translucent. And as we all know, even still, nanite does not support translucent surfaces, so that mesh couldn't be converted to nanite. So we ended up manually separating the mesh of the glass from it, convert the original mesh to nanite, and just set it up, I guess, either through Blueprint or just manually. Level artists would get that glass mesh back to the original mesh, but as a separate actor, so that wouldn't clash with the original mesh. So that's how we actually ended up with almost all our meshes that should be nanite. They were ended up as being nanite. There were some other smaller problems that would here and there annoy a couple of people. One of them being duplicate assets, in a sense of, I don't know if you ever use this type of workflow. When you are making a material, then you want a certain material function, then you just right-click on the material graph, and you get your drop-down menu. Then you say, okay, I want normal combine. And then instead of getting one normal combine, or maybe an engine normal combine function, you get and your own normal combine function, you get 5 of them from different third-party asset packs. That also was acted like a lesson, in a sense that, okay, we might not need, as we're always consolidating third-party assets with our materials. Their materials are not needed. They do not need to be in our directory. So we just nowadays we just flat out remove them. Anything that if we need a mesh from a pack, we just have the textures and we have the mesh, and that's it. Everything is our own. As it says here, most problems fixed. Had to live with some. I think in the end there were a couple of in the final build, the release build, there were a couple of materials that we didn't in the end consolidate because it was crunch time and burnout, and okay, let's just get it on, get it out. I don't want to see it anymore. Future efforts for this type of thing and how to handle. We are already very, very strict, and read that in a way where whenever I see and whenever I hear, okay, we need this type of third-party asset, I say, okay, do it right. And our lead programmer is actually leading an effort to actually create a separate depot for raw, unprocessed third-party assets. And almost like mega scans, you will be able to just pull from that depot your desired mesh or your desired texture, whatever it is, and just put it. It will then, with all the redirector magic and all the magic he will do, it'll be copied pretty much in your own production depot. But again, you'll have the responsibility of actually consolidating and actually making that asset production ready with the material consolidation and adjusting that mesh with our nanite pipeline. It's still work in progress, and we'll see what it brings in the future. Now on to the next, a bit smaller topic, but nonetheless important, is manual PSO caching. I think when you actually, especially if you are watching Digital Foundry, they're always harping about shader compilation hitches and all that beautiful stuff. Even if you're as a player and you get to that hitch, it's definitely annoying. We really did want to avoid that. So we actually tried to utilize the automatic PSO caching that was introduced. Someone will probably correct me. I think 5.2. But it wasn't at the time. It wasn't very well documented, if at all. And we had really no success. We ended up with a lot of error messages. We didn't really have time to debug all those stuff. So we opted for manual caching, which actually had better promise. And it was done for every level in the game. And this is how it looked. In the picture, you can see like the red spline. I tried to colorize it as best, but there's a lot of lines, and I didn't know how to hide them all. You can see the way how it was meant to work is you would have a spline that will go like all the way through the level, horizontally and vertically, to be like squiggly to get all of the level that you can get. And as the camera would follow the spline, it would also rotate around itself to catch every PSO creation it could. And it would run as a separate game mode, where you would, I think, run it as a commandlet. And it would take a couple of hours to like go through all the levels and generate and collect all those PSO caches, and then you would get all those collected PSOs and generate a cache, which then you would upload with your build. One thing to note is not all VFX could be activated and shown during that period, during that action. So we created a separate level with all the Niagara VFX already active and going on. So we would catch every possible VFX that was in the game, but wouldn't be caught in the ordinary level. The future work that was, I think, already made for the newly released DLC, and I think it showed success. I wasn't really too involved in it, but we have an AI bot that tests our puzzles and goes through the level and just tries to do your basic testing for you. We would apply that PSO collecting capability to the bot, and it would just do its own work without any setup for the spline. So that would avoid the laborious process of going through the levels and just doing the splines. And it would take a bit more time because the bot itself would just it wouldn't just go through the whole of the level. It would need more time for each level. Now, onto the other. I think this is the third before the end. Local volumetric fog. As I am the main lighting artist, this is maybe one of the dearest topics I like to talk about. The local, in a sense that it really increases the heaviness, the magic of the atmosphere itself. Why did we go with it? Because it gives you the large-scale heterogeneous fog with your 3D volume textures. It doesn't create a homogeneous fog if you only had a exponential height fog. Second use case was a dense low-lying fog for your spooky atmospheres, and it's really cool. That was done by having different layers of densities. It would all use the same 3D volume texture. It would use the same 3D volume shape, but the densities there were multiple densities depending on the world space height. We would have, I call it long distance God rays. Those were achieved with another layer of densities, but those were not world space. They were distance based from the player. Distance based from the player. You would have different types, different densities depending on how far the fog was from the player. And it's very, very handy tool to actually achieve dense God rays in the distance, but the fog near you wouldn't be too obstructing. Second, another little thing was a distance field based mask that would be interesting to you. It's not really something specific in a sense. Okay, it's used specifically for that, but it does add some interesting effect near objects. it would like avoid the objects, wouldn't like clip through it. But this is an exaggerated case just to see what it does. Material features that I want to actually add later is to try and fully implement the sparse volume textures that Unreal introduced in 5.3, I think. In 5.3, at least, they became fully functional. There are some content problems. I don't think they're related to SVTs as a system itself. More of a case, how do you actually generate a, let's say, a 3D Perlin noise? And I would also like to dabble with dynamism and interactability with the fog from the player, so render targets. There are 2 bonus chapters I'll try and just speed through. We have 10 more minutes. VSSM invalidation optimization. This is another magic feature that our lead programmer made. The biggest problem, the biggest cost we had in Talos 2 was from shadow depths. I think, excluding Lumen at least. Shadow depths were the biggest problem, especially in dense forests, because we heavily used wind. We used wind, which is derived from the world position offset. And as we all know, if you were at the Matt's talk, it invalidates the pages and it adds to the cost very, very much. The point of this hack would be to have your wind and try and eat it too. So when the player moved, the VPO would be disabled fully. So when the player moved in space and when the camera would be rotated, when you rotate the face, the VPO would be disabled, and when you stand, the VPO would again fade in somehow. It was not an ideal solution, but at the time it was a helper when it came to performance in denser parts of the levels, where the foliage was a bit more dense. It wasn't too immersion breaking, but we've seen a couple of Steam threads where they actually noticed and were talking about that type of thing. They were thinking it was a bug, but it's a hack. Now, in our future project, we'll probably not use this because of the set VSM behavior control. So a lot of our foliage now actually casts shadow, but does not invalidate, it casts shadow and moves with the wind, but does not invalidate. So the shadow itself is stationary, and we haven't seen any significant artifacts. I don't think I've even seen an artifact at all that I would actually call an artifact. So it's a pretty interesting thing. And last, but certainly not least, this is more up for discussion, and I would definitely like to discuss with people who use world. Can you show of hands who actually use world partition streaming? Nice. And so we were very heavy on world partition in our main game, and most of our levels used world partition streaming. And during our experimentation, I think 1 year before, not even 1 year, 6 months before the release, we did a lot of performance tests, and it did show significant performance increase, and the stability was definitely much better with world partition levels than in non-world partition levels. But a colleague of mine prompted me to do that again, and we did a somewhat a similar test post-release when all the content optimizations were done. So the point was we made 2 builds, 2 packaged builds. One build would be your normal world partition level with streaming and HLODs, and the second one would be, it would also be world partition, but the streaming would be disabled and HLODs would be deleted. So it would be like your ordinary level where everything was streamed in from the very beginning. And we haven't seen significant performance difference, and the stability itself was the same between them. But where the world partition was much more heavy on the runtime memory because of the HLODs, and it would be slow on some threads, but the overall frame time was pretty much the same. So from then on, for our future projects that that would use the similar size of the levels like in Telus 2, we opted to disable streaming at the start unless we really see that we need that type of performance optimization with streaming. So I'm definitely up for talking about this, and maybe we had some flaw in our testing that would show that maybe row partition does do something, but I haven't seen it. I did my triple checking, quadruple checking, but I haven't found a significant difference. So that's all for today, for this year. Maybe next year I might have something new for you. We'll see. And thank you all for listening. I hope you came out from here with something new. And if you have any questions, we have a couple of minutes, 5 minutes to see. Thank you, everybody, and enjoy the conference.